Lesson 4, we're going to look at frequency tables and histograms. So if you look on page 474, Mr. Maxwell timed the cross-country team in a 2-mile run and recorded the times in the table shown. He wants to analyze the runner's times. What is one way that Mr. Maxwell can organize the data? Well, it's going to be frequency tables and histograms, I can tell you. Okay, so if we look at this, you can look at the times in their table there. What they did, first of all, they did a frequency table. So this frequency table shows the number of times a value occurs in each category or interval. Now they had to come up with the intervals. They had to decide, how do we want to split up our times here? So they said, well, we're going to go by 2-minute intervals. 14 minutes to 15:59. 16 minutes to 17:59, 18 minutes to 19:59. Notice each interval, they're going by 2 minutes. Okay, the same amount of possible times for each interval. Okay, what they do then, the tally marks, that's just how many times that happened. Each time you see a number, put a tally mark. And then the frequency is just how many tally marks we had in that group. So 4 people, it took them 14 to 15:59. 6 people took 16 minutes to 17:59. 2 people, it took 18 minutes to 19:59. Okay, besides doing a frequency table, we can also make what's called a histogram. Histogram's kind of like a special type of bar graph. What's special about a bar graph called a histogram is that the bars are always going to touch each other, and it's using intervals of numbers on a histogram. It's involving numbers, where normally a bar graph, you know, we might say, what's your favorite color? And it might be words there. With a histogram, it's always going to be numbers. And it's always going to be the bars touching each other. The book gives just a sliver of space here in between these. Okay? So if you want to modify that, that's fine. But and then you can see here, it's kind of a more visual way that we can look at the stuff that we had on our frequency table. A little bit more visual, well, we can just look at that and kind of tell, well, yeah, 16 to 17:59, that's where, you know, that was our biggest group of people. On the Try It, we have a histogram that shows a different way to represent Mr. Maxwell's data. They want us to fill in the boxes with appropriate times, shade the bars for the last 3 intervals, have the intervals change. So if you look at this, what they did now, this would be a little bit easier for us to set up. We could maybe even set this up really without doing a frequency table first. And if you'll notice, they're just going by 1-minute intervals. So they went 14 to 14:59, 15 to 15:59. Next would be 16 to 16:59. We got 17 to 17:59. Next would be 18 to 18:59, and then 19 to 19:59. Okay. Now the nice thing about going by this kind of interval is that basically you can just look at the minute part of your number and you can tell what's happening. So looking back at the numbers, 17 to 17:59 for that bar, we're just going to look at how many times were 17 something. So 17 something, we have 3 numbers. So we'll go right next to their bar, and if you want to just draw some diagonal lines here in your bar, you don't have to fully shade this if you don't want, so where you have to sharpen your pencil every time you do a bar. 18 to 18:59, we have only 1. Again, put the bar right next to the other one. And 19 to 19:59, we have only 1 as well. Okay, so So to answer the other part of the question, how the intervals changed, we could say the intervals are 1 minute instead of 2 minutes. We already mentioned. It doesn't have to necessarily happen like this. On this particular problem, actually by doing that, there are half the number of values in the 1 minute intervals as the 2 minute intervals. So basically, our first bar was 4, now it got split 2 and 2. Second one was 6, now it got split 3 and 3. And the last one was 2, now it got split 1 and 1. Again, there's not a guarantee they're exactly going to be split in half, but each of those two numbers would add up to be the 2 minute interval that we had before. Look at example 2. Zach surveys a group of middle school students and asks them how many texts they sent yesterday. Table shows the results. This is a common mistake that the book's checking out with us here. Is the greatest number of texts sent between 60 and 79? Okay, a lot of times we do frequency tables and people look at this and the question is, what's the greatest number of texts sent? And everybody immediately looks at the frequency. 11, that's the highest frequency. It's 60 to 79. That's the highest number of texts sent. Well, no, it's not. That's the interval that has the greatest amount of people. It's the most popular of these, but it's not the greatest number of texts. There were people that sent between 80 and 99 texts. We don't know exactly the amount, but that's what the greatest number of texts sent was. Does that make sense?
Yes. Yeah.
Okay. Similar idea. Part B is the lowest number of texts sent between 20 and 39. Again, if you look at the frequency, it's the lowest frequency. It's not the lowest number of texts sent. There were people that sent 0 to 19 texts. Again, we don't know the amount that they sent, but somewhere in between there is actually the lowest number of texts that someone sent. So, if we look at the try it, how many students sent between 20 and 59 texts? So between 20 and 59 texts, if we look back at our frequency table here, 20 and 59, there were two groups between 20 and 59. So what we'll want to do is take the numbers there, those frequencies, and add those together. So we had 4 and 10. So if we'll just add those together, 4 plus 10 is a total of 14 people that sent between 20 and 59 texts. Example 3. Histogram shows the number of points Kendra scored during each basketball game she played last season. How many games did Kendra play last season? So this one, we're just going to look where the bars go to. So she has 3 games. She scored between 0 and 4 points. So that's 3 games. She has 6 games, she scored 10 to 14 points, so that's 6 games. 2 games from 15 to 19 points, and 1 game 20 to 24 points. So we'll just add those together. That's how they got that answer of 12 games. Okay, now part B, how many games did Kendra score from 5 to 9 points? Well, 5 to 9 points, if you'll notice there's not a bar there, which means 0 games. There's 0 times that she scored between 5 and 9 points. Now, this is an important point here that the book's mentioning. Even though it never happened, you still put the numbers there, okay? 0 to 4, 5 to 9, 10 to 14, and so on. Each one, they're going by 5s technically. I know it looks like 4s. They're going by 5s. 0 through 4. 0, 1, 2, 3, 4. That's 5 possible numbers. 5 through 9, 5, 6, 7, 8, 9, and so on. Okay, there's 5 possible numbers in each group. They've got them split up evenly again here. But again, since it never happened, even though she never got 5 to 9, we still put a blank spot there so we can see there's a gap. If we don't do that, if we just go right away to the 10 to 14, we don't see the gap in those number of points scored. So if we look at the try it, does the histogram show the mode of the number of points Kendra scored in the games? Okay, mode, remember, is a number or numbers that occur most often. Now we got to be careful with this one here. When we say we know what the mode is, we are saying specifically we know which number of points scored happened more than any other specific amount. For example, she scored 12 points more than any other number. Okay? She scored 25 points more than any other number. Can we pinpoint that based off of this? No. Okay. We could say the interval 10 to 14 happened the most often. That's an interval, though, not just a specific number. Okay? So the answer to this question, we would say then, no, the histogram shows ranges of points scored, not individual values. So we don't know an individual value that happened more than anything else here. Key concept just recaps things here, talking about frequency tables and histograms. Again, for a frequency table, intervals should be the same: 30 to 39, 40 to 49, 50 to 59, 60 to 69. It's going actually intervals of 10 there. Again, I know it looks like 9. Difference of 9 means 10 numbers. And the histogram then just displaying that information using kind of a bar graph here. So look at the do you know how number 5. We have a data set that contains ages ranging from 6 to 27, and they want us to complete the frequency table and histogram. Basically we're just taking and marking off these numbers. We've got 6 to 10 as our first group. If you want to just go through and find all your numbers from 6 to 10, that's fine. Okay, so it looks like only 2 people that were ages 6 to 10. 11 to 15. Again, if you want to go ahead and mark all those off, you can. Or you can just go individually, one at a time here. Okay, looks like 5 people were between 11 and 15 years old. 16 to 20. Looks like 2. 21 to 25 is 2 as well. And then 26 to 30 is just 1. So that would be our frequency table. Again, notice they went in intervals of 5, 6 to 10, 11 through 15, and so on. For their histogram, they've got this set up very nicely for us. Notice they have a title, ages in the data set. We have the ages underneath here. Maybe we should say ages in years. Might be obvious, but we've got 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30. And number of people, what's the highest frequency we had?
11 to 15.
Okay, what highest was 5. So can we go by ones here? Is that going to work?
Yeah.
Okay. Now one thing they've got in my book, they didn't really put a line for it here, but they did put it for their answer. We could probably normally would want to put a 0 there, which the book did that. They just didn't really give you a line to put that on. Might have been a nice idea. They just forgot maybe. Okay, so that's where that is. And then at that point, it's just making sure our bars are the right height. So 2, and then 5. Make sure your bars are next to each other. 2, 2, and 1. Look at workbook page 115. We're going to start with number 3. So they want us to use the data in the frequency table. Frequency table shows the time it took students in a PE class to run 1 mile. So number 3 asks how many students are in the PE class. In order to figure out how many students are in the PE class, we would just add our frequencies together. If you add those together, it ends up being 31. So 31 students in the PE class. Number 4, how many students ran 1 mile in under 9 minutes? So in this case, there's only one group that we have here that's under 9 minutes. So that would just be the 6 people there. Number 5, how many fewer students ran 1 mile in under 10 minutes than students who took 11 or more minutes? So how many fewer under 10 minutes than 11 or more minutes? Okay. How many fewer kind of gives us the idea we are going to be subtracting here in a minute. So let's look at under 10 minutes. So under 10 minutes actually is going to be the first 2 groups here. Both of those groups were under 10 minutes. So if we just add our frequencies together there, so under 10 minutes, 6 plus 2 equals 8. And then the other group we're looking at is 11 or more minutes. So for that one, 11 or more minutes, this would be the last 2 groups here. So for that one, we would be adding 6 plus 9, which is 15. So the one, we had 8 people. The other one, we had 15 people. If we subtract those, then 15 minus 8 is 7. So we had 7 more that took 11 or more minutes than those that ran it in under 10 minutes. Okay. Number 6, can you tell from the frequency table how many students, if any, ran a mile in exactly 12 minutes? So look at the frequency table. Do we know exactly 12 minutes how many people did that? No. Okay. Again, it has to do with that these are intervals, not exact times. Okay. So we could say no, there aren't exact times listed, something like that. Just ranges of times or intervals of times. Look at number 7. Just as Lila finished making her histogram, a group of 5 people started playing. Now her histogram is ruined. She wants to include their ages, which are 12, 12, 16, 26, and 48. How should Lila change her histogram to include these ages? Basically, it's just a matter of that we're going to change the bars a little bit here. So 12 and 12, those would both be in the 6 to 15 group. So we would just increase that bar by 2. Up to 10. We got a 16. Would increase this by 1 up to 6. 26 would actually give us a bar. Now notice the lines are going by 2s here, so don't go all the way to that line with that one. And then 48 would increase this by 1. up to 3. Okay, so basically just changing the bar heights is going to be how we would change the histogram. Number 8, Lila recorded the ages of miniature golf players at 3 o'clock p.m. How might her data change if she recorded the ages of players at 7 o'clock p.m.? This is kind of a debatable thing, but potentially 7 p.m. versus 3 p.m. Some people might be at work at 3 p.m. They might be off work at 7 p.m. So a possibility would be, we could say there could be more people who are 26 to 55 years old at 7 p.m. Again, this would be maybe after they get off work. Okay, and again, that's a generalization. Everybody has different hours that they work in different situations, but just an option of what might happen here. Number 9, going back to what we were just looking at with the last couple problems, suppose a 65-year-old brings her 2 granddaughters to play miniature golf. The granddaughters are both 5 years old. How can Lila adjust the intervals to include these ages? So this actually is going to extend both directions. This would now be a younger and older people than what we had before. So one option would be going technically intervals of 10. We could go 0 to 9 years old, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69. That would be one option. Another option, 5 is the youngest that we have, so another option besides doing that, a different option, you could do something like 5 to 14, 15 to 24, and so on. Okay, that's going to have a little bit more of an impact on our frequency table, or our histogram rather, because the intervals really should be split up equally, equal intervals of possible ages when we do a histogram like this. Look at number 10. Each day for a month, Bo timed himself to see how many free throws he could make in 60 seconds. Using the histogram, select all the true statements that describes Bo's data. Okay, so each day he's doing this. So the first question, there were 31 days in the month, and basically if you just go through here, we've got 6, 8, 11, 5, and 1. 6, 8, 11, 5, and 1. And if you add those together, you do actually get 31. So that one checks off. The second one, Bo made 15 to 19 free throws 6 times. If you look at that, that's actually in between 4 and 6. That'd be 5 times, not 6 times there. So that does not work. More than half the days, Bo made at least 10 shots. Well, at least 10 shots, that's going to be these last 3 groups here. So more than half the days. So we'd need at least 16 total for that to happen. We've got already 11 in that first one, and then a 5 and a 1. So that's 17. That's more than half. So that works. Greatest number of shots made was between 10 and 14. Going back to what we looked at earlier, it's not the greatest number of shots. It's the greatest interval of shots, but the greatest number of shots was somewhere between 20 and 24. So that does not work. Bo made fewer than 10 shots more often than he made more than 14 shots. So fewer than 10, that's going to be the two bars we didn't just look at a minute ago. Be our first two bars here. So that'd be 6 and 8. 6 and 8, so 14 that were fewer than 10. And then more than 14. More than 14, that'd be just the last two here. So that would be the 5 and 1. That'd be 6. So yeah, quite a bit more times that he made fewer than 10 than he did to make more than 14. So this gives you an idea of how to display data in frequency tables and histograms.